In this lesson, we'll talk about system of coordinates and linear equations. Rectangular, sometimes called Cartesian, coordinate system consists of two perpendicular number lines, called axes, intersecting at a point that is called origin. This point will have coordinates 0, 0. Such system will allow us to identify each point on the plane with an ordered pair of numbers x, y. This pair of numbers will represent the horizontal x-coordinate and vertical y-coordinate. The two axes cut the plane into four regions that are called quadrants, and those quadrants will be numbered counterclockwise. That means this way, starting from the upper right quadrant. So let's see how it looks like. We have two axes, the x-axis and the y-axis. They are positioned perpendicularly, with the common point being origin. And since both axes are really number lines, so we already have established scale on each axis. We have some numbers like 1, 2, 3, 4, and so on, and negative numbers to the left. The arrow on the number line indicates that the numbers are increasing in that direction. So there is a common notion to place the arrow to the right if it's horizontal, and if we talk about vertical number line, we'll place the arrow up. It's not always that we have to do it, but that's the most commonly used way of setting up the coordinate system. So these two horizontal and vertical axes cut the plane into four regions, and those four regions are numbered counterclockwise like this. Quadrant 1, 2, 3, 4. Okay, let's plot some points with given coordinates as listed. 0, 3. That means that starting from the origin, we are moving 0 steps, no movement, along the x-axis, and 3 steps along the y-axis. So the point 0, 3 is here. Next point 3, 2. Starting from the origin, we are going 3 steps along the x and 2 steps in the y direction, up. So the point 3, 2 is here. Let me write it down, 3, 2. You see, if we project this point onto the x-axis, it points out to the number 3. And if we project this point perpendicularly onto the y-axis, it will point out to the number 2. So 3 is the first coordinate, 2 is the second coordinate. You may want to plot the rest of those points by yourself and check in a second against my work. So the point -4, -3 is -4 on the x and -3 along the y-axis. So that's the point, -4, -3. And next one, -5, 0. Okay, 5 steps to the left and 0, no vertical movement. So the point is really on the x-axis. Next one, 2, -1. So 2 horizontally, -1 vertically. So that's the point, 2, -1. And finally 0, -5. No horizontal movement, but 5 steps down along the vertical axis. So again, we obtain a point on the y-axis. As I mentioned before, origin has coordinates 0, 0. Okay, so here we have 0, -5. Over there, -5, 0. And this one is 0, 3. A little remark here. If we work with different letters than x and y, the rule is we go by alphabetical order. That means we assign the first letter that appears in the alphabet to the horizontal axis, and the second one will indicate the vertical axis. So we don't have to have x and y, it could be p and q or r and s. And if we use, let's say, this rs system, that would mean that the first coordinate is called r and the second is called s, because r is first in the alphabet. Similarly here, the first coordinate will be called p and the second q. Okay, why did we recall the system of coordinates? Because we'd like to graph the solutions to certain equations. So what's a graph? What's a graph of an equation in two variables? Well, this is the set of all possible points of a plane with coordinates that will satisfy the given equation. So graph of an equation, or later on graph of a function, would be the set of all points satisfying this equation or belonging to the function. How do we graph a linear equation? Let's recall the methods that we studied before. The first method is by using table of values. This method always works, however, it's a little bit lengthy and time-consuming. We just draw a table, take some input values x, and figure out the corresponding values of y, the values that will satisfy the given equation. For example, if we have this equation 3x minus 2y equals 1 and would like to graph it, we pick a few x values, and from the equation we figure out what's the y value. But we could do the other way around as well. We could pick some y values and figure out what's the corresponding x value. That doesn't matter. Customary we start with x, but sometimes it's useful to replace y as well. So in this particular table of values, I suggested to pick numbers like -1, 1, 3. Pick numbers that will be easy to calculate. So if x is -1, we replace x in our equation by -1, so -1 times 3, it's -3. Copy the rest and try to figure out what the y would be. Well, that would be -2. Y equals 1 plus 3 is 4. Then when I divide by -2, my y becomes -2. So I can fill up my table by placing -2 that corresponds to -1. Okay, let's try to change the value of x. This time x is 1. So that will be 1 times 3. Oh, that will give me 3 here. So I can just erase this minus. And I need to calculate what's y from this equation. Well, here I could move this term to the right, making it 2y, and move the 1 to the left. 3 minus 1 is 2. Finally, divide by 2 and y by itself would be equal to 1. And fill up this box. So x equals 1 corresponds to y that also equals 1. Well, you may want to check 3 by yourself. Plug in 3 instead of x, so we have 3 times 3, so it's 9. And again, 2y equals 9 minus 1, so it's 8. Therefore, y by itself is just 4. Plug in 4. Finally, the last example, just for change, I used y value -4, and let's see what the corresponding x value would be. But first, let's erase whatever we had before. So, this time y is -4, so we have equation 3x minus 2 times y, which is -4, equals 1, and we're solving it for x. So we have 3x, 2 negatives makes it plus 8 equals 1. Therefore, 3x equals 1 minus 8 is -7. And finally, x equals -7/3. Well, as you see, this produces kind of ugly number, fractional number, but we can still estimate. -7/3 is equal -2 and 1/3. So this can still be estimated when plotting a point. Okay, now it's time to plot our points. Those are the points given by coordinates, for example, -1, -2. So let's plot it. -1, -2 is here. Then 1, 1, 1, 1 is over there. 3, 4, 3, 4. Oh, it's here. This is our 4. This is our 3, and that's 1 and 1. We should have at least one number on each axis to indicate the scale. And you see, the last point is maybe not so easy to plot, but we can still approximate it. -2 and 1/3. -2 and 1/3, it's approximately here. And then I need to go down -4. 1, 2, 3, 4. So our point is somewhere there. So when you look at these 4 points, they seem to lie on the same line, which confirms that our calculations were correct. Normally, to draw a line, it's enough to have 2 points. However, in order to be sure that we didn't make any mistake, it's safer if we do at least 3 points. Here I've got 4 points, but maybe 4 it's a little bit much. 3 should be okay. Why more points than 2? Because if by any chance we've done any mistake with one of the point, it may be positioned somewhere else. For example, if this point will be here, we would see that something is kind of crooked. It doesn't look like a line. So that should give us a red alert. Oh, let's check our answers. There may be some mistake there. And that gives us some security that we double check our work, so it will protect us from some errors. Okay, when we already have all those points that seem to lie on the same line, well, let's join them and we produce our graph. So that will be our graph of this equation. Notice that this graph consists of infinitely many points, so we can't really check all of them. However, knowing the structure of the equation, since x and y are in first degree, that's a linear equation, so we expect our graph to be a line. That's why it's enough to check 2 or 3 points and then connect them to have the full graph. Okay, let's erase these extra calculations. So as you see, that was quite a bit of work to fill up this table of values. And we do know a little bit easier methods of graphing a line. For example, the next method is x and y intercept method, which is a little bit shorter than this table of values, but it still uses a little table. This method is very useful when we have our equation given in a standard form, exactly the form that we had here. That was standard form, ax plus by equals c, where x and y are variables and a, b, and c represent constants. So let's recall this method. Let's say we want to graph 5x plus 2y equals 10. That's a standard form of an equation of a line. So the x-y-intercept method goes like this. We make a little table for x and y, but this time the values that we pick for x or y are very specific. We pick just 2 points. X could be 0 or y could be 0. So those are the special points. Remember, to find x-intercept, we set y to 0 and then find out what the x is. So this point gives us x-intercept. And to find y-intercept, we set x to 0 and find what the corresponding y is. So this will give us the y-intercept. Okay, let's check. If y is 0, to find x, it is enough just to cover the 2y, because 0 times anything is still 0. So this term totally disappears, and what we end up with is just 5x equals 10, which is easy to calculate in our minds. X would be 10 divided by 5, so it's 2. Okay, the corresponding x is 2, so we have the first point that we can plot in the system of coordinates. 2, 0. As you see, this point is positioned on the x-axis, so yes, that's x-intercept. Let's check the y-intercept. Similarly as before, we replace x by 0. So this term disappears, and we really end up with solving just this simple equation 2y equals 10. So y would be equal 5. Okay, we place 5 here. We have the x and y intercept. Let's plot this. 0, 5, 2, 4, 5 is here. And that was 2. We have these two intercepts, and we are ready to graph the line by joining them. So as you see, this method is a lot shorter, and it works very well as long as we have nice numbers. For example, this number is easily divisible by the coefficient by x and by the coefficient by y. But that happens quite often in our exercises, so try to use it. Okay, the next method is my favorite one, slope-intercept method. Let's recall the structure of linear equation in slope-intercept form. We have y equals mx plus b, where x and y are variables and m and b are our coefficients. Recall that in the slope-intercept form of a line, m stands for slope, which is defined as rise over run. So it's a ratio. Even if this number is a whole number, for example 2, you can always see this 2 as a ratio just by dividing by 1. So that will be rise 2 and run 1. Sometimes this coefficient is negative, and since when we write a negative number, it doesn't matter if the negative is in front of the number, in the numerator or denominator, my suggestion is to keep the negative always with the numerator. That usually helps when graphing. Why? Because the denominator represents run. And to me, running, it always goes forward. It's like time, always goes forward. So we like to use positive direction. Now, let's recall what's b. Well, B represents y-intercept. Why? Because if x is 0, then this term disappears and the y would be exactly equal to b. So yes, indeed, this is the y-intercept. The point 0b belongs to the solution of this equation. And 0b lies on the vertical line. So yes, it is a y-intercept. Okay, let's try to use the slope-intercept method in order to graph this particular line, y equals 1/2 x plus 1. So what do we do first is to start with the y-intercept. In our case, the y-intercept is 0, 1, this number. So we start with 1 on the y-axis. And then we go by slope. So again, remember, rise over run. Starting from this point that already belongs to our future line, we run 2 units and we rise 1 unit. So our destination becomes here. That's our 2, and from 1, and we have 2 here as well. Okay, so the road was 2 steps across and 1 up. That's our run part, and that's our rise part. The good thing about using this method is we don't have to calculate anything and we can develop as many points as many we wish to. Not only these two, but we can repeat this process, and again, since this point belongs to our future line, we can still go by the slope to develop another point. Again, 2 steps across, run 2, rise 1, and we get this point. We also could go backwards, so we already know the pattern. It was 1 down, 2 to the left, so 1 down, 2 to the left gives us this point, and again, and that's definitely good enough to graph our line. That's our line. So that's why I like this method the most, because it does not involve any calculations. We just need to recognize the parts of the equation. This is the y-intercept, that's a slope, go for it. Now notice that if the y-intercept is actually 0, then what will happen? Well, the line will cross the origin. That means that any equation of the form mx will pass through the origin. Let's see one example. We already know first point, it is the origin because the b number is 0, right? And then we go by the slope -3/4. Again, as I said before, I like to run first. The indication how far I'm supposed to run is in the denominator. I run positive number of steps, which in this case it's 4. So I run up to here, and then normally I would rise, but since this negative belongs to the numerator, we call it falling. So instead of rising, we're falling 3 steps. 1, 2, 3. We're landing here. Okay, so what's the coordinate here? -3 on the y-axis. And those are the 2 points that needs to be connected. Let's connect it, and here's our line. Let's look at a couple more equations and lines. Those are the special cases. For example, let's say we want to graph equation y equals 2. How can I see this equation in a form mx plus b? Well, on the right-hand side of this equation, I only have a constant number 2. So that looks like b. But I don't have any term with x. So what does it mean? What does it suggest about m? Well, m must be 0 in this case. So if I want to follow this strategy, graphing by slope-intercept method, I would have to start with the y-intercept 2, which is, let's say, here, and then I will have to go by the slope 0. But 0, that really means 0 over 1. So I can run 1 step, and I'm not rising or falling at all. I'm stable. So this point will be connected with that point. And again, I run 1 step, but I'm not rising and not falling. And again, and again, and again, and also to the left. It's no vertical movement, just horizontal movement. So if we connect all these points, we have a horizontal line. So this kind of equation represents a horizontal line, and also we know that the slope of a horizontal line is equal to 0. Okay, let's check the second special case. In this equation, we don't have y at all. So Can we rewrite this in a slope-intercept form? Well, no, because we can't even start. There's no y in this equation. So let's check a couple points that will satisfy this equation. We know that x must be equal to 1. Let's mark 1 here. So a point 1, 0 would satisfy this equation. If x is 1 and y is 0, no problem because y is not even there. So actually y can be anything and will still be satisfying this equation. For example, 1, 2, 1, 4, 1, negative 1. All those points still satisfy this equation. Well, let's plot them. So 1, 0 we have here, 1, 2 over there, 1, 4, 1, negative 1, 1, negative 3, and so on. All these points seem to be lining up along this vertical line coming through the point 1. Let's join them. Yes, we have a vertical line. So generally, any equation of the sort x equals a constant number gives us a vertical line. And what would be the slope of a vertical line? If we take 2 points, for example, this one and that one, we can't run at all. The running part, the horizontal displacement, is 0. So no matter how far we can rise, for example, if this will be any number and we are running 0, well, that's not allowed. We can't divide by 0. That's why the slope of a vertical line is said to be undefined. We can't divide by 0. There is no running part. Horizontal line, slope 0. Vertical line, slope is undefined. Let's put those observations together. Generally, any line of the form y equals constant is a horizontal line with slope equal to, yes, 0. And any line of the form x equals constant is a vertical line with slope that is undefined. Notice that slope 0 doesn't mean undefined. Slope 0 means that a moving point is not climbing or not falling. However, undefined slope means that the point can't really move forward or backwards. It can only move up or down.